Welcome to Miracle Knowledge Hub. This is the place where every video brings you wisdom, positivity, and inspiration to brighten your day. Whether it's life lessons, motivational thoughts, or powerful knowledge, we're here to guide you on a journey of growth and happiness. Each video is designed to help you think more clearly, live a better life, and stay inspired. So, join our community of dreamers and learners, and let's spread knowledge together. Don't forget to like, share, comment, and subscribe to stay connected and never miss an update. This is Miracle Knowledge Hub, where knowledge creates miracles. Welcome to our video on NASA, the United States' premier space exploration agency. Did you know NASA has forgotten more about space than many of us will ever learn? Let's dive into its remarkable journey. NASA, established on July 29, 1958, is an independent agency focused on civil space programs and aeronautics research. It took over from the National Advisory Committee for Aeronautics, aiming for a peaceful focus on space science. NASA headquarters is located in Washington, D.C. Under the administration of Sean Duffy, NASA manages an annual budget of approximately $25.4 billion, employing around 17,960 staff as of 2022. Now that you have a brief overview, let's explore NASA's key milestones. NASA's rich history began when the U.S. sought to reclaim its aeronautics leadership after World War I. The agency launched its first satellite, Explorer 1, in 1958. The success set the stage for iconic missions like Project Mercury and Apollo. During the height of the Cold War, President John F. Kennedy famously pledged to land a man on the moon by the end of the 1960s. His vision became reality with Apollo 11 in 1969, when Neil Armstrong took one small step for mankind. After Apollo, NASA shifted its focus to the Skylab space station, international cooperation with the Apollo-Soyuz mission, and ambitious robotic exploration programs. Fast forward to today, NASA continues to innovate with programs like the International Space Station, the Commercial Crew Program, and the Artemis lunar missions, aiming for a sustainable human presence on the moon and beyond. NASA's scientific contributions help us understand Earth and the cosmos. Instruments like the James Webb Space Telescope and Mars rovers like Perseverance explore distant worlds, providing insights into our universe. Want to engage with NASA's discoveries? Check out NASA's official website. Dive into the thrilling stories of space exploration with us, and stay tuned for future launches, missions, and discoveries. Join us as we continue to uncover the secrets of space. The origins of NASA. A journey into space exploration. Have you ever wondered how NASA came to be? This discovery begins in the backdrop of the Cold War and the space race. In 1958, NASA was born from the National Advisory Committee for Aeronautics, or NACA. The competition to explore space between the United States and the Soviet Union fueled its inception. NACA was involved in aviation and rocket experiments since 1946. They famously tested the supersonic Bell X-1. However, everything changed with the launch of the Soviet Union's Sputnik 1 on October 4, 1957. The U.S. faced a Sputnik crisis, leading Congress to demand swift action. They established the need for a new agency focused on non-military space activities. From late 1957 to early 1958, NACA began brainstorming what a civilian space agency could look like. On January 12, 1958, NACA created a special committee on space technology. This committee was led by Guyford Stever and consulted experts like Wernher von Braun, who brought crucial knowledge from his wartime work. On October 1, 1958, NASA officially launched. The Lewis Flight Propulsion Laboratory became the NASA Lewis Research Center. Less than a month later, on January 31, 1958, NASA launched its first satellite. Explorer 1, designed to study cosmic rays, marked a turning point in American space exploration. This was just the beginning. In March 1958, insights from experts like James Killian led to proposals for strengthening NACA into a comprehensive space agency. President Eisenhower recognized this necessity. In April, he proposed the formation of a National Aeronautics and Space Agency. Congress passed the National Aeronautics and Space Act on July 16, 1958. With this act, NASA absorbed NACA and other resources, including talent from the Army Ballistic Missile Agency. Innovations from the German rocket program set NASA's future in motion. By December 1958, NASA controlled the Jet Propulsion Laboratory, boosting its capabilities significantly. The journey from NACA to NASA was marked by urgency and determination in the face of international competition. In summary, NASA emerged not just as a space agency but as a cornerstone for American innovation and exploration. Are you excited to learn more about NASA's missions? The legacy of the Space Shuttle. NASA's pioneering program. Did you know that NASA's Space Shuttle program made history with 135 missions? From 1981 to 2011, this iconic program transformed space exploration and technology. Let's delve into the intriguing story of the Space Shuttle system, its components, and its impact. The Space Shuttle, also known as the Space Transportation System, STS, consisted of three main components: the deployment of satellites, the conduct of scientific research, and the servicing of the orbiter, external tank, and solid rocket boosters. Constructed predominantly by United Space Alliance, the shuttle's mission was to launch crewed missions into low Earth orbit. It was roughly 56 meters tall and weighed over 2 million kilograms. During its operational years, the Space Shuttle enabled various missions, including deploying satellites, conducting scientific research, and even servicing the Hubble Space Telescope. Notably, it participated in the construction and maintenance of the International Space Station. Let's break down its key components. The orbiter carried the crew and cargo, featuring three powerful 25 rupees engines. The external tank supplied the necessary propellant. The solid rocket boosters provided much of the thrust for liftoff, producing an astounding 27 million newtons of power. The Space Shuttle made its first flight, STS-1, on April 12, 1981, piloted by John Young and Robert Crippen. It completed numerous missions over the years, with remarkable achievements, including the deployment of the Galileo and Compton Gamma Ray observatories. Tragically, the program experienced significant losses. The Challenger disaster in 1986 resulted from a failure of the booster O-ring, leading to the tragic loss of 7 astronauts. In 2003, Columbia disintegrated during re-entry due to damage sustained during launch. NASA's commitment to safety was scrutinized after these events, leading to improvements in shuttle technology. Flight operations were enhanced, training became more rigorous, and safety thoroughness intensified. In total, the shuttle had an extraordinary mission time of 1,323 days, conducting various scientific and engineering operations. The program officially ended with the last flight, STS-135, on July 21, 2011. The Space Shuttle remains a symbol of human ingenuity and exploration, paving the way for future missions, including those using Artemis technology. Many of the components from the shuttle have been adapted for the next generation of space exploration, ensuring its legacy continues. Project Mercury. The dawn of American human spaceflight imagined the thrill of rockets launching into the sky, signifying a historic leap for humankind. Welcome to Project Mercury, America's first human spaceflight program, a groundbreaking journey from 1958 to 1963. This ambitious endeavor was initiated by NASA, born from the urgency of the space race against the Soviet Union. The primary aim? To send an astronaut into orbit and return him safely. During this period, 20 uncrewed flights paved the way for 6 crewed missions, culminating in our astronauts' celebrated achievements. The Mercury era commenced with a staggering budget of $277 million in 1965, approximately $2.76 billion today. Despite its costs, the project achieved remarkable milestones, including significant advancements in spacecraft technology and astronaut safety. One iconic moment occurred on May 5, 1961, when Alan Shepard became the first American in space during the Mercury Redstone 3 mission. His 15-minute flight aboard Freedom 7 set the stage for future astronauts. Shortly after, John Glenn followed as the first American to orbit the Earth, demonstrating that the U.S. could hold its ground in this exhilarating race. The Mercury spacecraft design evolved to ensure astronaut safety and mission success. The capsule was equipped with a launch escape system and mini rocket thrusters to manage re-entry. Each launch was meticulously organized, with astronauts undergoing rigorous training to handle the extreme conditions of space. Throughout the program, the Mercury 7 astronauts gained immense popularity, capturing the public's hearts. Their missions were broadcast on radio and television, gripping audiences worldwide. These heroic figures engaged with the community, fostering a spirit of exploration that inspired generations. Despite some setbacks, such as the tragic loss of the Liberty Bell 7 capsule, the Mercury program yielded invaluable lessons and accomplishments. By its conclusion in May 1963, the United States and the Soviet Union had both launched 6 missions into space, a testament to the fierce competition that defined the space race. Mercury not only laid the groundwork for future programs, such as Gemini and Apollo, but it also ignited a collective fascination with space exploration. Today, its legacy continues to inspire innovations and education in human spaceflight. Want to dive deeper into the history of space exploration? Apollo program. One giant leap for mankind. Have you ever wondered how humanity set foot on the moon? The Apollo program is a captivating tale of innovation, ambition, and success. This remarkable journey reshaped our understanding of space travel and exploration. The Apollo program began in the United States in 1961, led by NASA. Its main goal was to land humans on the moon and return them safely to Earth. It lasted until 1972 and had a staggering budget of $25.4 billion, equivalent to $257 billion today. It included 32 successful missions, 2 failures, and 1 partial failure. The first crewed flight was Apollo 7 in 1968. It wasn't until the historic Apollo 11 mission in 1969 that astronauts Neil Armstrong and Buzz Aldrin became the first humans to walk on the moon. Their footsteps left a lasting impression, with a total of 12 astronauts exploring the lunar surface across 6 missions. Exploration began with careful planning. Initially, the program focused on developing a 3-person spacecraft. However, John F. Kennedy's vision on May 25, 1961, shifted the program's direction towards a lunar landing. NASA faced many challenges, including a tragic cabin fire in Apollo 1 that took the lives of 3 astronauts. Despite setbacks, technological advancements flourished during the Apollo missions. Saturn V rockets, designed for powerful launches, propelled astronauts on their journeys. Each mission involved several steps, including launch, translunar injection, and lunar landing. The procedures transformed into a well-orchestrated effort. Apollo missions were not just about reaching the moon, they were scientific endeavors. Each mission returned lunar rocks and soil, contributing to our understanding of the moon's composition and history. Apollo 15, Apollo 16, and Apollo 17 further extended lunar exploration, with Apollo 17 being the last manned mission in December 1972. While Apollo achieved its core mission, it also laid the groundwork for future space explorations. The program significantly advanced technology in rocketry, telecommunications, and computer software. It stimulated a surge in technological innovations, benefiting various industries. In popular culture, Apollo left a remarkable mark. From memorable moonwalks to iconic images like Earthrise, it inspired countless generations. The program effectively demonstrated what humanity can achieve through determination and resourcefulness. In summary, the Apollo program is a monumental chapter in human history. It showcases persistent effort and the unwavering spirit of exploration. The remarkable achievements of Apollo remind us that, as John F. Kennedy said, choosing to go to the moon was not just about the destination but the journey itself. The adventure doesn't stop here, it's just the beginning. Exploring the International Space Station, a gateway to space research. Have you ever wondered what it's like to live and work in space? The International Space Station, ISS, is the answer. Orbiting Earth since 1998, it's the largest human-built structure in orbit and a marvel of modern science and international collaboration. The ISS isn't just a space station. It's a laboratory, observatory, and factory, all rolled into one. Operated by NASA, Roscosmos, ESA, JAXA, and CSA, it hosts crews conducting groundbreaking scientific experiments in microgravity. Imagine working alongside astronauts from around the world. To understand the ISS better, first, let's look at its structure. The station is divided into two main sections: the Russian orbital segment, ROS, and the US orbital segment, USOS. Each section supports different functions, from living quarters to scientific experimentation labs. Now, let's dive into its purpose. The ISS serves multiple roles, from supporting research in fields like biology and physics to helping us prepare for future human missions to Mars. It allows researchers to study phenomena that can't be replicated on Earth. For instance, the alpha magnetic spectrometer aboard the ISS is detecting dark matter and is as revolutionary as the Hubble Space Telescope. The data coming from these experiments have profound implications for our understanding of the universe. Moreover, living aboard the ISS isn't just about work. It also includes a routine that keeps astronauts healthy. They exercise for 2 hours a day to combat muscle atrophy and bone loss caused by microgravity. Their nutrition is carefully managed, with fresh foods flown in regularly, adding a touch of home to their diet. The ISS also emphasizes education and outreach. Over the years, crew members have engaged with students on Earth, conducting experiments they designed and inspired in the classroom. In the future, the ISS aims to continue its mission until at least 2030. Plans include adding new modules to enhance its capabilities. After its operational life, NASA has planned a controlled deorbiting to ensure it safely re-enters Earth's atmosphere. To summarize, the ISS stands as a monument to what humanity can achieve through cooperation and innovation. It's a hub of scientific discovery that pushes the boundaries of human exploration and understanding of the universe. Excited about space exploration? Don't miss out. Space Station Freedom. The journey from vision to reality. Have you ever wondered about the ambitious Space Station Freedom project? This NASA-led initiative from the 1980s aimed to create a permanently crewed space station in low Earth orbit. Initially approved by President Reagan, Freedom faced significant budget cuts and delays, eventually transforming into part of the International Space Station we know today. Freedom was envisioned as a multinational collaboration. NASA partnered with NASDA from Japan, ESA from Europe, and CSA from Canada. Despite the billions invested, about $11 billion by the project's end, many designs contributed to the creation of the ISS. After the Apollo program concluded in the late 1960s, NASA explored future programs. Central to these were three emerging themes: a crewed Mars mission, a permanent space station, and a space logistics vehicle. In 1972, the Space Shuttle was selected to serve as the pivotal launch vehicle, aimed at reducing costs. As initial studies progressed in the early 1980s, NASA outlined the purpose of Space Station Freedom. It was seen as an orbiting repair shop, a microgravity research lab, and an assembly point for spacecraft. Reagan's announcement in 1984 marked a significant commitment to this vision. Studies followed, but choices needed to be made. NASA developed a database of potential missions extending beyond 1984. Early shuttle missions included spacewalks to test construction techniques for a future station. In 1984, the Power Tower design emerged. This configuration was purposeful. Its structure provided gravity stability, and it featured modular designs, allowing for efficient operations. In late 1986, NASA sought to lower costs by revising the design. The revised baseline configuration considered a phased assembly approach. This solution promised viability while controlling expenses. By 1988, contracts were signed, and hardware fabrication began. However, budget constraints continued to affect the project's trajectory. Revisions were made, reducing the size and capabilities of Freedom significantly. The project was redefined multiple times due to fiscal challenges, often losing scientific capacity in the process. By 1993, as discussions shifted, leadership changes created uncertainty about Freedom's future. Questions arose about its necessity, with concerns about costs dominating the dialogue. In October of that year, an agreement with the Russian Space Agency emerged. Eventually, in 1993, the vision for Space Station Freedom transformed into the International Space Station, ISS. The collaboration included Russia, scaling back the design and intentions even further. By 1998, components were launched to begin assembly, and long-term residents arrived in 2000. In summary, while Space Station Freedom never reached completion, its legacy continued. The groundwork paved the way for the successful International Space Station. NASA's journey showcases the complexities of designing projects in response to changing political and fiscal landscapes. If you found this story intriguing, explore more about space exploration and the evolution of missions that shaped our understanding of the universe. Did you know that the International Space Station, or ISS, is the most expensive object ever built? It represents incredible international collaboration in space exploration. Today, we'll dive into the ISS program, its history, significance, and operations. The ISS is an ongoing project run by 5 participating agencies: NASA, Roscosmos, JAXA, ESA, and CSA. Established in 1993, It was a collaborative solution following the failure of independent space station projects. 15 nations actively support the ISS, emphasizing space cooperation and scientific advancement. The program's cost is staggering, totaling around $150 billion. Spanning from its first flight in 1998 to the present day, the ISS has been instrumental in advancing our understanding of space and life beyond Earth. The operations of the ISS are complex, involving intricate legal frameworks set by international treaties. These agreements govern everything from ownership rights to crew responsibilities and cargo resupply missions. The ISS serves as a microgravity laboratory, allowing scientists to conduct experiments that are impossible on Earth. Over the years, several nations have contributed to its expansion and sustainability. Spacecraft like Soyuz and SpaceX's Dragon have transported astronauts and supplies. Currently, the ISS has astronauts from various nations aboard. It initially housed 3-person crews but has expanded to 7 with the arrival of larger commercial vehicles. Maintaining the ISS comes with challenges. It has faced several maintenance issues, affecting operations and sometimes risking crew safety. However, collaboration among the partner nations has allowed for effective problem-solving. The future of the ISS is also a point of interest. Discussions around extending the program beyond 2028 are ongoing. Space tourism is another exciting aspect, with private citizens being able to visit for a price. This not only generates interest but also funds future efforts. The ISS has faced criticisms, too. Some argue that resources could be better allocated elsewhere. Despite the debates, advocates stress its importance as a platform for scientific research and international connection. In summary, the ISS is a landmark of global cooperation in space exploration. It pushes the boundaries of science and sets the stage for future crewed missions beyond Earth's orbit. Thanks for tuning in to Miracle Knowledge Hub. Turn knowledge into an advantage. If you enjoyed this video or learned something new, don't forget to give it a thumbs up. It helps the channel grow a lot. We'd love to hear your thoughts, questions, or reflections. Leave a comment below and join the conversation. And if you haven't already, be sure to subscribe and turn on the notification bell so you don't miss out on powerful content that inspires, informs, and transforms. Don't hesitate to share this video with friends or family who could benefit from this knowledge, because miracles are meant to be shared. This is Miracle Knowledge Hub, where knowledge meets transformation.